Okay, number 1. Have y'all read it? You've already done problems like this. You did some problems like this in pre-calculus, and probably maybe in Math 3 or Math 2 you did some problems like this. That a picture will help you because it helps me identify what you're trying to find. If you put your X where I have put the Y and you put your Y here, that's okay. But I need to know that that's what you did so that I can tell why your answers are backwards from mine. Okay? So in some way you got to explain to me how you're doing the answers. So anyway, the picture is helpful. Okay, the first thing you're going to do, you're going to have 2 equations on most of these. One equation is going to be like it has X's and Y's with it and a number. Okay? In this case, 200 is in the problem. That represents the amount of fencing that there is. Okay, so how would I do anything with the 200?
Perimeter.
Okay, so what would be the perimeter on this problem?
4x plus 2y equals 2.
Not 2y.
Be 3y.
Because we're going to put fencing in the middle too since we're doing these corrals.
Okay, so it's not like they're together.
Mm-hmm.
Where did that come from?
There's 4 x's, 1, 2, 3, 4, and there's 3 y's. Okay, it also tells me that the area is going to be a maximum. So that tells you what the other equation is going to be. The other equation is not going to have an answer with it. It's just going to be a letter equals something with x and y. Okay? So we know that it's going to be area because it says area will be a maximum. And so what's the area of this thing?
Length times width. Which is x, 2x times y.
Okay? So after you get the 2 equations, you're going to solve one of the equations, the one with the numbers, either for x or y, and you're going to plug it into the other equation. Okay? So which one should I solve for? It really doesn't matter, but there's one that's easier than the other.
X.
If I solve for x, I got to divide by 4.
You can just solve for y.
If I solve for y, I have to divide by 3.
That'd be equal.
Dividing by 4 is easier, right? Because 200 divided by 4. So I'm going to solve for x. So I get x equals, or 4x equals 200 minus 3y. Divide by 4, so x is 50 minus 3/4 y. Questions? So you get the 2 equations. You solve the one that has all numbers in it for either x or y. And then you go back and you plug that into the second equation. Not for y. In this case, we're doing it for x. So we would have area equals 2 times 50 minus 3/4 y times y. You're with me so far?
So why wouldn't you plug in the x into the equation 4x plus 2y equals 200 to find y?
Because that was the equation I was solving. When the equation that you solve for, you don't ever plug that back into that equation. If you do, you'd get 0 equals 0, and that one doesn't help you. The equation that you solve for, you plug that into the other equation. All right. If I'm trying to find a maximum, what I know about calculus is that I need a derivative. I'm going to set it equal to 0. I'm going to make a number line. Then I'm going to say it's a maximum. I'm going to do all the things that we've been doing. Okay? So from here, it should be like a normal thing as far as the whole process. On this one, before I find the derivative, though, I want to simplify it. Like I want to take this 2y and multiply by the 50 and the 3/4 y because it would make it easier to find the derivative. If you'll simplify whatever that equation is first, it'll make solving the derivative easier. So we get 2y times 50, which is 100y. And then we get 2y times 3/4 y, which is negative 3/2 y squared. Everybody still good?
Did you, like, never mind, I guess it doesn't matter.
is this, does y prime come in right here?
Now you find the derivative. Set it equal to 0. Solve it.
Wait, isn't it 3/2?
Wait, what happened to the y
I
prime?
want- What's the derivative? 3/2 times 2. I'm solving for y. I took the area prime. And I'm skipping a couple steps because I want to be able to show you how to do each of these problems.
Where's the y prime?
Now you make your number line. I'm going to put 0 on my number line to remember that I'm not picking things below 0 because we're talking about lengths or we're going to talk about money or things like that. So it's after 0, so we're talking about something like that. We're going to plug in numbers into the derivative. I'll tell you if you do, you get a positive and then you get a negative. You can check that later. Be sure to say that there is a max at x equals 100 over 3, since f prime of x changes positive to negative. Go back to the question real quick and find out what it was asking. It says what's dimensions. If it would have said find the area, then I would take the value I got and plug it back in to get the area. But it just says find the dimensions, so the dimensions I need are y and x. I already have y. Be sure to write the units as well. That's feet. But then I need x. Go back to all the problem and find any place where you have y in the equation where it says x equals something. So I would do it here. X equals 50 minus 3/4 y. Just plug the y into there. And I think you get 25. So the points, you'll get points for the derivative, you'll get points for the number line, you'll get points for telling me it's a maximum, you'll get points for the units, the feet. If you don't say the feet, you lose points.
So for the 25,
Okay, so this one has fencing, and then there's a river. And they're not putting fencing on the river.
I think the hardest part for me is like understanding what it's saying. Like
That's why we're going through the equations, because that is the hardest part. It says the pasture must contain 180,000 square meters. Okay, that right there tells me something important. What is that supposed to be? That's supposed to be the area. And I know that because it says square meters. If I'm unsure about whether that's perimeter or area, think about the units that it's in. Okay? So I know that that represents the area. The area is 180,000. I'm going to let this be y and x. I normally just let the up and down one be y, but again, it doesn't matter which way you do it. So that equals xy. Okay, the other part of the problem says what dimensions would require the least amount of fencing. So the part that's the least or the minimum or the maximum, that's the second equation. It's talking about the amount of fencing. So I'm just going to call it an F. You can call it M for minimum, or you can call it P for perimeter, but it's perimeter. You're talking about the amount of fencing, that's the outside, right? And what would the fencing be on this problem? Make sense? Which equation are you going to solve for x or y? You solve for x or y in the equation that has numbers. You can't solve for x or y in the bottom one because there's an F there. The one that's the minimum or the maximum, that's the one you want everything to plug into so you can find the derivative. Because since I want the derivative or the minimum fencing, I've got to find the derivative to see where the minimum is located. Okay, now when you work this one out, I'm going to tell you you get like a weird thing for the derivative, and I just want to show you this. You get this for the derivative. It's actually negative 1 minus 360,000 x to the negative 2, but if you'll write it as a fraction, and then set it equal to 0, you can solve that. I'm just reminding you how you solve that. If you subtract 1, cross multiply, and then you can take the square root to get to the answer. I think it's 600. It tells me that you're enclosing a 3,000 square foot garden. So what does that mean? 3,000 square foot. That's the area. So that is x, y equals 3,000. Do you agree? Okay. Then it says about this cost. It says find the minimum cost. So cost is the second equation. That's the equation that you're going to take the derivative of and set equal to 0, because that's the minimum. How am I going to figure out the cost? The cost of the fence side is $10. The cost of the shrub sides are $25. So it's going to be 10x plus 50y plus 25x. X and y are the length of the sides.
Wow.
Okay, so it's 10x plus 25x plus, if you want to go ahead and write 50, that's fine. I'm just writing it out so you can see each side was multiplied by the cost on that side. Any questions on that? Basically, you'll solve for either x or y. It really doesn't matter on that one. Plug in for whichever it is here. It might be easier to solve for x since there's only one x, so there's only one thing you'd have to plug into. Okay?
This is true.
Okay, number 4. Okay, the pool is the blue part. And it says it has an area of 1,800 square feet. So if I call that y and that x, what is that telling me? Okay, then it tells me about this 5 foot and 10 foot thing. I did 10 foot here and 10 foot here. You can do it other way. It really doesn't matter. So we're building this deck and we want 5 foot on one of the sides and we want 10 foot on the other side. And it's asking me the dimensions of the smallest property. So the property is this whole entire thing, deck and pool. It's the area of that. So what's the length of the bottom here?
X plus 10.
X,
X plus 10, because this is X, the middle part's X, and then we're adding 5 to each of them to get that whole side. So what's Y plus 20 on the other one? That's the area, because it's Y and then plus the 2 tens. And so on this one, you'll solve for either X or Y at the top, plug it in for X and Y here, simplify it a little bit, I'd multiply it out probably, and then find the derivative and do everything. Questions? Okay, number 5. Okay, this was a problem I know you did in pre-calculus, but it's basically saying that you got some kind of material and you're cutting off squares on all 4 corners. And then you're folding them up. We now have a box, right? Just want to know about the volume of that box once you fold them up. Okay, and it's wanting to know what size square should I cut off so that this volume is the maximum. Okay? We're going to call the length of the square x.
It's a square, so it's the same.
All the squares are x. Yes. So we know that the volume is length times width times height, right? Sometimes when you see this picture, like you've probably seen it before, it's a picture that looks like this. And we're cutting off those little squares on it. And then think about it folding up. That's the height, right? The amount that you're cutting off, that's the height. That's the X. Okay. So it's telling me that each side is 24. So if that side's 24, and then I fold it up, what's the length of that side now? 24 minus 2x, because I'm folding up both sides. Right? 24 is the length of the whole thing. I'm folding those two pieces up to make the box, and I'm getting rid of the parts that I cut off.
Is the thing that started with a square?
Yes. It says so. And so on the other side, it's 24. Still cutting off those two x's because I'm folding them up. This problem is different from the others because you only have to have one equation. You don't have to have two equations like you do on the others. And that's because the first equation we come up with has volume and x's all in one equation. It doesn't have three variables. To solve this one, you got to multiply that out. I'd multiply the 24 minus 2 x's out, FOIL it, then multiply by x, then take the derivative. And remember, our answers don't have to be just regular numbers. They can be fractions and decimals. Okay, last one. Tells me that my base, it's a rectangular solid, and it tells me that my base is a square. So right there's my base. This part right here is the base. And this up here is the top of it. So these are the sides. Okay? It tells me it's a square, so I'm going to call them x's. And I'm going to call the y like the height of the box. Make sense? It says it wants to maximize volume. So the volume equation going to be what? Length, width, and height.
X squared.
The other thing it talks about is surface area. And surface area is the area of each of the sides all added together. Right? Okay, so let's think about the bottom. What's the area of the bottom? And what's the area of the top? So there's 2x squareds, right? What's the area of a side? XY. Because it's x times y. Is all the sides xy? So how many of them are there? There's 4. So there's your two equations. You're going to solve that strange surface area formula for x or y. Which one are you going to solve for, x or y? Y, because there's only one y. The fact that there's two x's on that surface area equation makes that hard to solve for x. I'd solve for y. And then plug it in there and then work it out.